Alright, as promised, I'm going to go over some sections in chapter 4 of our course right here, and some topics from number theory. So we're going to start with divisibility and mod arithmetic. So this is called divisibility, and we're going to talk about modular arithmetic. In a short form we call it mod. So I don't know if any of you has done it before. I'm assuming you have not. So let's talk about divisors. So divisor is basically what it is in mathematics. So if I say 12 divided by 3, we know the answer is 4. And then if you say, let's say 11 divided by 4, the answer is 2.75. They both worked. One has a decimal, one has a round number. So when you use the word divisibility, the quotient, so in this case the quotient can be either 0 or decimal. So suppose we have two integers. So suppose we have integers. Let's just give it a name A and B, and make sure that A is not 0 because we're going to divide something by A. Then we say, this is what we say: A divides B if there exists, remember the notation for there exists, an integer C such that you can write B as A C. In other words, C is an integer where you can write it as B over A. So that's the whole idea here. So if we can write, so in this case this is going to be 4 equals 12 over 3, right? In other words, A divides B. So this is your B, this is your A, this is your C. So we will say 3 divides 12. Is that correct? So 3 divides 12, but the way you write it, the notation, you have to be careful. This is 12 divide 3, right? 12 over 3, 12 divide 3. But when you use the word or the sentence 3 divides, you will use a vertical line, 3 divides 12, which means how many times can 3 go into 12? So in this case, 3 divides 12, in other words, 12 over 3. So you have to be very careful how you're writing your notation. It's not slanting. So you need to have completely whole number in order for this to happen. So there must exist a number. If it doesn't exist, then you will say it does not divide. So we will say A divides B, right? A divides B means what do you need? There exists a C, right? But if A does not divide B, then no such letter C. So let's take a look at an example right here. E.g. example. So if I say 3 vertical line 7, in other words, I'm saying 3 divides 7. That means how many times can 3 go into 7? 2 times, but there is a remainder. But there is a remainder. So there is no such number where I can do the division directly. So you will say 3 does not divide 7. Therefore, I cannot write 3 divides 7. My question, does 3 divide 7? What about example, let's say 3 divides 12. How many times 3 goes into 12? 4 times, right? So 3 divides 12. So basically, this is how you do. Whenever I say 3 divides 12, the homework solution should look like 12 over 3 should give me 4. And this may look easy because it's a very simple number, but usually in this level you're going to do a lot of proofs, right? So in order for us to do this, we're going to take a look at some theorems, and these are the theorems you're going to see in your homework or your next exam. So suppose we have three integers A, B, and C. Then I'm saying A is not 0, so that's a divisor, right? So we have several cases. If A divides B and A divides C, which means how many times A goes into B, how many times A goes into C, then we can actually say that A divides both B plus C. I'm going to put in a parenthesis because this is basically B plus C over A. It's just a common denominator, right? That's one case that we can see for divisibility. If we have A divides B, then we can say A divides BC for all integers C. And then finally, the other theorem, part 3, that you need to know, if A divides B, and let's say this time B is the divisor, B divides C, then we can say that A divides C. So if you notice in this case, B is the numerator. For the second case, B is the denominator. If this is the case, then what we're trying to say that C divides A. And you will definitely have to do some actual real world number in order to figure this out. Okay, the next section I'm going to take a look at is the division algorithm. So division algorithm, so you need to know this algorithm for your homework. So I can say use the division algorithm to answer this question. So the theorem for division algorithm, we did learn what is theorem, is already proven, right? So suppose we have two integers. Suppose we have A and D are two integers where D is a positive integer. So we don't want to deal with negative here. Then we say, then there exists a unique, remember this notation? There exists a unique integers Q and R where R is between 0 and D. So I have 0 here, D here. Remember, D is a positive number. R falls under here. So R can be 0, but it has to be less than D, such that, so if I have A and D, I can write A equals DQ plus R. So it's basically, it's kind of algorithm, it's just a divisibility. So in equality, we call D is the divisor. So D is the divisor, which means what? So what divides what? So this will be D, and then I'm going to have some answer right here, and then I'm going to have some remainder right here, and this is going to be the quotient. So whatever we get here, A is going to be Q, D times Q plus R. So that's the idea behind the scene right here. So you're trying to find out how can I do a division by using this method. I will do some examples later, either in the later part here or maybe in the class later. So D is the divisor, A is called the dividend, that means the one that you're going to divide, usually that's a numerator. Q, as I said earlier, is called the quotient, And of course R, as I mentioned earlier, is called the remainder. And the special notation that we will use a lot in this class is going to be Q, that's a quotient, is A div D, and then the remainder is going to be A mod D. You will learn what is this pretty shortly. So in this case, we're going to say that A div D and A mod D is just for a fixed D of functions in the set of integers. So A div D, that basically means A divide A over D, right? And A mod D is basically A minus D. So that's how we will actually compute these things. So let's take a look at an example so that you will get a better understanding what this means, right? Okay, so suppose you have the question, what are the quotient and remainder when, so suppose when 101 is divided by 11. So the question is find the Q and R. So we can write this, remember we can write this as A equals DQ plus R. Can I write this as 101, that's my A, equals 11 times 9 plus 2? Yes, right? So how did I get this? Basically, this is what we did. 101 divided by 11. And how many times does this go in there? 9. So you get 99 and your remainder is 2. So that is the idea right here. So you're going to have your dividend, which means that's the number on the numerator. And then what's outside here, that's the number, your divisor, right? That's your D. Quotient is how many times that it goes into, and then after doing some math, you're going to get a remainder. So the way we put all this together is you take A equals D times Q plus R. So if you look at the example that we just did right here, isn't that exactly the same? That you got A is 101 equals 11 times 9 plus the remainder 2. So your quotient is 9, your remainder is 2. And the way you would write it using these notations that I just said here is going to be, so when 101 is divided by 11, that's going to be what's quotient? Quotient is 9. So 9 is 101 divides 11, and then the remainder is going to be 2. 2 is going to be 101 mod 11. So this basically what it means is how many times it divides, right? And then this basically means whatever remainder that you have. So the way we did that, remember, is A minus D. A minus D, what was A? 101, right? Minus D was 99. So you are only left with 2. Okay, so that is A mod D. So now let's go and see what is the meaning of mod. Mod is modular. So modular, so that was division. This is modular, and the short form for that is going to be mod. So mod is if suppose you have two integers A and B, and you have m, another integer, we say a is congruent to b mod m if m divides a minus b. So basically the notation that we're going to use for mod right here will be a is congruent, absolutely congruent or similar or same, b mod m. So this is the notation to indicate that a is congruent to b if m divides. So this only is true if m divides a minus b. So when do a minus b, and when you divide, that is called congruent. And then m is the modulus, or plural modulus is 1, plural is moduli. But here we're just going to do modulus. If it is not congruent, then of course you're going to say it is not congruent, right? Okay, so now let's take a look at an example here.
I'm having trouble connecting.
So suppose, well, ignore my Alexa here. So we want to see an example. Does 17 or is 17 congruent to 5 modulo 6? And then the other one is 24 and 14 are congruent to modulo 6. So let's do the first one. So the answer is since or because 6 divides 17 minus 5. So what is 17 minus 5? So the question is 17 congruent to 5 mod 6? This is only congruent if and only if 6 divides 17 minus 5, correct? Remember from the previous page? So 17 minus 5 is 12. So in other words, 6 divides 12, right? So you don't have any balance or left over. So we will say since this divides this, then 17 is congruent to 5 mod 6. So that's how you would write it. Okay, so what about, so let's call that A, and let's say we want to talk about 24 now. So are 24 and 14 congruent to mod 6? So let's take a look at it. 24 minus 4 is equals 10. So you see is not divisible by 6. Why? Because when you divide it by 6, you do have a remainder 4. So you will say 24 is not congruent to 14 mod 6. So hopefully that example really helps you to understand what is the meaning of modular and do simple questions like this. Okay, so let's say we have an example. Let's say another example. I'm going to do 18 and write it in mod 5. So can we write that 18 is equal 7 plus 11? Is that right? That is right. So 7 plus 11 is equals 2 plus 1, which is 3 mod 5. So in other words, what's the easiest way for us to understand mod is how many times can 5 go into 18? Only 3 times. And that's how you end up as is 3, but you're going to have some remainder, 3 mod 5. So if you did 18 minus 3, you're going to get it's divisible by 5. So basically that's how mod works. Okay, there is a special formula that we have. You can take a look in your textbook or example, but don't worry about it. That's not going to be in the exam. I'm going to ask you something that's simple and not crazy, where you have to really go out of the way to answer the questions. I think that will end this section, and when we meet again, I'm going to go over other sections. I will not talk about this, so make sure you have studied it on your own and you understand, so that you know how to answer your example in your exam. Alright, see you guys in class pretty soon.